Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. So in the previous video, I discussed about zero input response. So when we solve for the zero input response of a given linear differential equation, okay, we have to find the roots of the characteristic equation. Now, in that video, I say that in our course, okay, we only cover second order system. Okay, so when you try to find the roots of a second order system, there are four cases that will occur. Okay, four different cases. So I will show you in this video the different roots that you will get and what is the general solution of the zero input response for each different cases. So for case number one, when you find the roots, okay, of the characteristic equation, which is lambda, okay, the first case that you can find is real and distinct roots. Okay, so you will have lambda 1 and lambda 2. Two different values. So the general equation of the zero input response, okay, will be like this. Okay. Y0 of t is equals to C1e lambda 1t plus C2e lambda 2t. Okay, so this one, okay, we have seen in the previous video how we end up getting this equation. So if you solve for this Y0 of t, okay, if you differentiate this, you will get this equation. For the case number 2, okay, you might have real and repeated roots. Means your lambda is equal. Lambda 1 and lambda 2 are equal. Okay, so this will be the general solution of the zero input response, Y0 of t. And if you differentiate this, you will get this Y0 dot of t, okay, which is useful when you try to solve using the initial condition. For case number 3, you will have a complex roots without real components. Okay, for example, like this. The lambda is equals to plus minus j. This b here is constant. For example, you might have plus minus j5 or lambda equals to plus minus j10, for example. Okay, so this b is put into this equation here. So your general solution of the zero input response is given by this equation. So if you differentiate this, cos, it will be a sine function like this. Case number 4, you might have a complex roots with real components. Okay, for example, lambda equals to a plus minus jb. So these a and b are constant. Okay, so you might have lambda equals to 2 plus minus j5, for example. Okay, so the general solution of the zero input response will look like this. Okay, so the exponent now is to the power of at and the cos bt plus theta. If you differentiate this, you will get the equation at the bottom here. Okay, so here I have prepared 4 different sample problems, okay, with 4 different roots, okay, in order for you to practice the equation given in the previous 2 slides. So this is problem number 1. Problem number 2, you are given the characteristic equation and initial conditions. Find the zero input response. This is for question number 3 and question number 4. Okay, so I will see you in the other video where I will show you the solution to all these sample problems. Thank you.